This video is an introduction to the Sigma Metalytics Precious Metal Verifier Pro. Like the Precious Metal Verifier, the purpose of this instrument is to assist in determining the authenticity of precious metal coins and bars. The measurements the Pro makes are based on the idea that if you know the weight and the volume of a sample and you measure the resistivity all the way through a sample, there is no way that we are aware of that metal could be fake. The Precious Metal Verifier Pro measures the resistivity all the way through the sample and also helps the user measure the volume and therefore the density of the sample. Looking over the instrument, we see the display, keypad, and two sample areas. The sample being measured is placed between the sensors to obtain a reading. This large sensor is for samples 30 millimeters or larger in diameter, and the small sensor is for samples down to about 10 millimeters in diameter. Let's take a typical sample and see how the instrument helps with these measurements. Here is a 1 ounce silver maple leaf coin. We want to check its authenticity. Set the instrument for silver and for 1 ounce troy. Place the sample in the large sensor. You see on the display there are two main readings taken. The top bar graph is a measure of the resistivity of the bottom side of the sample, typically a ½ millimeter into the sample. This bar corresponds to the reading obtained by the original Precious Metal Verifier. On the right, there is a numeric value that shows the resistivity of the sample. The second bar graph is a measure of the resistivity all the way through the sample. The instrument uses sensors on both sides of the sample to accomplish this. If these two readings agree, then it is very likely there are no foreign materials inside the sample, such as inserts or holes. Note, there is a numeric reading next to the second bar as well, and this number is the through reading. So far, so good. We know resistivity corresponds to the expected value for the metal. There is one more measurement the instrument performs and will allow the user to determine the density of most samples. You can see here on the display a thickness value is shown, and since the weight was entered and the density of the sample is known because the alloy was entered, we can calculate the sample area or diameter expected. In order to make this measurement, notice there is a soft key dim over the measure button. Press this key and a screen comes up that asks if the sample is round or rectangular. For this silver coin, choose round and press the enter key, and a bar is shown on the screen. Also, a light appears near one of the vertical lines next to the display. At this point, move the sample so that the right edge of the coin is on the lit line. Look at the screen where the left edge should be within the green band. If the left edge is within the green band, then the coin is the correct volume for the weight of this metal. We have measured the density of the coin to be correct. At this point, we know the verifier resistivity reading on the bottom of the coin and all the way through the sample. And we know the volume and therefore the density of the sample as well. Given that all these measurements are consistent with the selected metal and weight, there is very high confidence that the sample is authentic. Next, here we have a 10 ounce silver bar. Let's look at how a bar measurement works. Place the sample in the large sensor. Set the weight on 10 ounces. The metal is already correctly set at silver. Once more, we have the readings consistent with silver, so that's good. Let's check the volume. Push the dim button, answer the shape question with rectangular this time, and press enter. A rectangle shows up on the screen and a light is lit next to a vertical line to the right. In this case, we will line the bar up with this top line and the right lit line like this. Now we use the up and down arrows to move the horizontal line to the screen until it's right at the edge of the sample. Notice that the left side of the sample is in the middle of the green band, indicating the sample is the correct density for silver. Therefore, this sample is consistent with silver in surface resistivity, bulk resistivity, all the way through the sample, and in density. Sometimes pure copper is used to fake silver bars and coins. So let's assume a piece of copper were silver and see if it can pass the test for silver. Here is a bar of very pure copper. First enter its weight, then place the sample under the sensor. Note the readings are in the yellow. So this is cautionary, but it could still be impure silver. Note the readings are the same, so there doesn't appear to be any different materials inside the bar. So far, although we have a caution, it does meet the criteria for impure silver. Now, measure the density by pressing the dim button. Setting rectangular and moving the sample down to the lines as we did before. Move the horizontal displayed line up and down to get it lined up with the edge of the sample. Now we look at the left edge to see if it is in the green bar. And lo and behold, it's outside the green. The density is not correct for silver, the sample is not consistent with silver, and we say the sample is not silver. It turns out the substantial majority of samples are round or rectangular enough for the density measurement shown. There, of course, are samples shaped like bullets and other odd shapes which can't be sized in this way, but the substantial majority of samples can be measured this way. As a last demonstration, let's show how the through measurement can spot different material inside a sample. Here are 2 copper plates. Set the instrument on copper. In this case, ignore the weight. Measure the copper stack. As you can see, it is consistent with copper in both the bottom measurement and the through measurement. Note the values are a little different, and this is due to the air gap between the plates. Now, we insert a piece of tungsten. Note the top measurement is still consistent with copper, but now the through measurement is significantly out of range for copper. You can see the instrument has detected the tungsten insert, showing the metal is not consistent with copper all the way through. So, we've shown the features of the new Precious Metal Verifier Pro. First, it measures the resistivity all the way through, the original PMV does. Second, it measures the resistivity all the way through the sample and can spot any inconsistencies in the reading caused by inserts and voids. Third, it can measure the volume and therefore the density of the sample to validate the density is consistent with the selected metal. With these measurements being consistent with the selected metal, in addition to its weight, there's no known way the sample can be inauthentic. Thank you.